For nearly 200 million years, a dynasty of giants held dominion over the Earth. Their reign seemed absolute, etched into the very rock of the Mesozoic era. Yet, beneath their colossal feet, in the shadows of immense ferns and conifers, another story was quietly unfolding. The story of the creatures that would one day inherit a shattered world.
To understand this epical struggle, we must journey back beyond the first dinosaur, to a time when the blueprint for both lineages was still being drafted. The trail leads to the preceding Paleozoic era, where the evolutionary roads for reptile and mammal finally diverged. Both paths began in the water, with primitive labyrinthodont amphibians, creatures descended in turn from the ancient lobe-finned fishes. From these aquatic ancestors, the labyrinthodonts inherited a flat, heavy skull, a piece of anatomy with openings only for the eyes and nostrils. This design was a prison. Lacking efficient lungs and mobile ribs, they breathed by gulping air, forcing them into a form that would change little over the ages.
But for those who broke free, who mastered true pulmonary breathing, evolution offered a cascade of advantages. As reliance on gulping air vanished, the skull was liberated. It became smaller, lighter, and more complex. Crucially, new openings appeared in the temporal bone, gateways for powerful jaw musculature to anchor and expand. It was here, in the architecture of the skull, that two destinies were forged.
One group developed two such openings. They were the Diapsids. This lineage would give rise to the dinosaurs, the pterosaurs, and all modern reptiles. Their dental system was one of endless replacement. A lost or broken tooth was simply shed and a new one erupted. But this convenience came at a cost. Without a permanent set of teeth, a precise interlocking bite was impossible. They could rip and tear, but they could not truly chew. This path led many of them toward bipedalism, their forelimbs shrinking as they rose to walk upon two legs.
Untold muscles. They were the Synapsids. This was the path that led to us. In the Great Triassic Dawn, some 220 million years ago, the first true mammals emerged from this line. They were small, nocturnal, living in a world that trembled under the footsteps of the ascendant Diapsid giants. One path led to a thunderous, spectacular, yet ultimately ephemeral reign. The other was a quieter, more patient strategy of survival, a testament that the future does not always belong to the titans of the present, but to the survivors hidden in their shadows.
In the deep past, life on land fractured into two great dynasties, two rival blueprints for vertebrate existence. This schism would define the next 300 million years, a silent war of bone and blood that continues to this day. On one side stood the Diapsids, a lineage that would give rise to the titans of the Mesozoic, the dinosaurs, the pterosaurs, the great marine reptiles, and whose modern descendants include crocodiles, lizards, and the birds that fill our skies. Even the snakes, which in a remarkable evolutionary turn abandoned their limbs entirely, belonged to this sprawling dynasty.
The secret to the Diapsid success was a revolution in cranial design. Theirs was a skull not of solid, immovable bone, but of kinetic architecture. While our own jaws are a simple hinge, the Diapsids engineered a system of profound mobility. Not only did the lower jaw move, but in many, the upper jaw could flex and pivot independently. The lower jaw itself was not a single bone, but a composite structure, its two halves joined by elastic ligaments. This anatomical marvel transformed the head into a living gape, an instrument capable of swallowing prey far exceeding its own dimensions. It was a strategy of overwhelming consumption, compensating for teeth designed for gripping, not for the meticulous work of cutting and chewing.
Within this dynamic frame, the brain was housed not in a sealed vault, but in a cavity more akin to an open tube. It was a simpler instrument, a design of primal efficiency suited to a world governed by instinct and reflex. For millions of years, this design was supreme. With bodies fueled by the sun, their cold blood a testament to an older way of life, they were the undisputed masters of their world.
But another path was being forged. Our own ancestors, the Synapsids, chose a different strategy. Their evolution was a story of consolidation, of building a fortress. Early in their journey, they developed a monolithic skull, a solid, unified structure designed for protection. This cranial vault would become the bedrock for the future of intelligence. Within its walls, the brain was free to expand, to complicate, to dream.
Mosaic of 6 or more bones, the synapsid jaw began a relentless march towards singularity. Over eons, the extraneous bones shrank, detached, and embarked on one of evolution's most elegant journeys, migrating into the middle ear to become the delicate apparatus of hearing. What remained was a single, powerful bone on each side, dentary. This transformation can still be witnessed in the living fossils of Australia. The echidna and the platypus, relics from the dawn of mammals, retain features that echo this ancient past, a living bridge to the age before the dinosaurs.
This new jaw, anchored in a solid skull, allowed for a momentous innovation: occlusion. The teeth were no longer simple pegs for grasping. They diversified into incisors for slicing, canines for piercing, and molars for grinding. For the first time, the complex process of digestion could begin in the mouth. Food was not just swallowed, it was processed, its energy unlocked with unparalleled efficiency.
Yet, in the beginning, this new model was slow. The early synapsids walked with their limbs splayed to the sides, their bodies slung low, hanging between their legs in a clumsy reptilian waddle. The Diapsids, meanwhile, were swift, their gait more direct and powerful. For a time, it seemed our ancestors were destined for mediocrity. But as the Triassic period waned, a profound change occurred within the synapsid lineage. In the first true mammals, the limbs migrated, rotating from the sides to a position directly beneath the body.
The torso was lifted from the earth. This structural revolution dramatically increased the efficiency of movement, conserving muscular energy and enabling sustained speed. It was this adaptation, born in the shadows of their diapsid competitors, that gave our distant forebears a crucial advantage, allowing them to survive the long reign of the dinosaurs.
Two paths struck from a common ancestor. One, an explosion of kinetic form, dominating the world through scale and adaptability. The other, a slower, more deliberate path of internal fortification and metabolic fire. One gave the world its most spectacular monsters, the other, its most intricate minds. The conflict is long over, yet its legacy is written into every living creature. The bird that soars overhead and the beast that walks the earth remain the living monuments to a choice made when the world was young.
Before the reign of the dinosaurs, another dynasty held dominion over the earth. This was the age of the Synapsids, the distant ancestors of all mammals, and they were conducting a grand evolutionary experiment. Deep in the humid forests of the Carboniferous period, they began to grapple with one of life's greatest challenges: the mastery of internal fire. This was the dawn of homeothermy, the ability to regulate one's own body temperature, dorsal sails, long thought to be warm the blood or cooling it in the oppressive midday heat.
By the close of the Permian period, this lineage had triumphed. Synapsids were the apex predators and the colossal herbivores, occupying every significant niche on the supercontinent of Pangaea. The world belonged to them. There was no indication, no prophecy written in the fossil record that an age of giant reptiles was even a remote possibility. The Permian fauna was a rich tapestry of these proto-mammals, a world of profound diversity that seemed destined to endure. Even the Great Dying, the Permian Triassic extinction that annihilated over 90% of marine species and 70% of terrestrial life, did not immediately shatter their rule. But from the crucible of this global catastrophe, a new form emerged. The archosaurs, the ancestors of dinosaurs, began to challenge the old guard, and they possessed a revolutionary advantage. It was a change in posture, a fundamental shift in locomotion. They rose up on two legs. This bipedal stance granted them a level of speed and agility the sprawling Synapsids could not match. The contest was decided first among the hunters, fearsome paced by the swift, relentless theropods. It was a brutal calculus of speed and power, and the bipedal archosaurs held the winning equation. The old kings were relegated to secondary roles, their shadows shrinking until they vanished from the world entirely. Among the plant eaters, the transition was a slower, more drawn-out affair. For millions of years, herbivorous synapsids coexisted with their dinosaurian rivals, a long, fading echo of a former supremacy. Then, as the Triassic gave way to the Jurassic, the world turned. The descendants of the once mighty synapsids were pushed into the margins. The first true mammals appeared some 200 million years ago, born from a hardy line of cynodonts who had weathered the Permian extinction. For the next 150 million years, for nearly two-thirds of their existence, they would live in a world ruled by giants, a dynasty in miniature, thriving in the shadows of the dinosaurs.
Their survival was predicated on a simple, yet profound evolutionary strategy. They remained small. As the dinosaurian world spiraled into a relentless pursuit of gigantism, the heirs of the Synapsids shrank. They were no larger than modern mice or shrews, a size that made them an inefficient meal for a Tyrannosaurus. In this small-scale world, these insectivorous mammals could compete and even flourish, hidden in the undergrowth and the darkness of the night.
Among these early mammals, one group achieved an almost unbelievable level of success: the multituberculates. Their name derives from the complex, multi-cusped molars that made them masters of processing tough plant matter, seeds, and insects. In form, they were the great pretenders of the Mesozoic, evolving into shapes uncannily similar to the rodents that would one day replace them. Most were small, but some grew to the size of a modern beaver. Over 200 species have been described, a testament to their adaptability. Some burrowed into the earth, others climbed trees with the dexterity of squirrels, and a few even evolved, a hidden empire thriving beneath the feet of the dinosaurs. Their story is one of astonishing endurance. They arose in the late Triassic, lived through the entire reign of the dinosaurs, witnessed the asteroid impact that ended the Cretaceous, and survived for another 30 million years into the Cenozoic, only finally vanishing in the Oligocene. In total, they persisted for roughly 175 million years, one of the longest-lived and most successful mammalian orders of all time. Their eventual extinction, long after their colossal rivals had turned to dust, serves as a stark reminder. Survival is not a reward for past success, and no dynasty, no matter how resilient or long-lasting, is promised tomorrow. Evolution does not move towards a final goal, it simply moves on.
For a span of time as long as the entire reign of the dinosaurs, they lived in the shadows. A secret, parallel world thrived in the undergrowth, a world of fur and warm blood, moving through the night while giants shook the earth. Among these early mammals were the multituberculates, a lineage of staggering success, persisting for over 150 million years. Their name whispers of their secret: teeth covered in a complex landscape of cusps and ridges, not for tearing flesh, but for grinding and crushing the tough cellulose of the Mesozoic flora. This was evolution's first truly effective attempt at crafting a small-bodied herbivore. The challenge was immense. To break down plant matter, an animal requires a gut teeming with symbiotic microorganisms. For the cold-blooded Diapsids, the reptilian rulers of the age, maintaining the necessary internal temperature for this microfauna demanded a simple, brutal solution: sheer size.
They became colossal furnaces. But the mammals, with the revolutionary fire of homoeothermy burning within them, had solved the problem. Their constant internal heat allowed them to host these digestive partners without the burden of gigantism, unlocking a world of opportunity in the forest's lower strata.
In their quiet diligence, these multituberculates may have played another profoundly important role. They became the first gardeners of a new world. Analysis of their powerful jaws and specialized teeth suggests they consumed large, hard objects. In the Jurassic, these would have been the tough nuts and seeds of ancient gymnosperms, cycads, ginkgos, and towering araucaria. Later, as flowering plants began their gleaning these seeds, they were not just feeding themselves, they were active agents in the greening of the planet, co-evolving with the very plants that would one day dominate the Earth.
But another, more audacious strategy was unfolding in the twilight. While most carnivorous mammals of the era were no larger than shrews, by the late Jurassic period, the shadows began to birth their own giants. They were the triconodonts, and by the standards of their time, they were titans. To our eyes, they were scarcely larger than a wildcat, but in a world where mammals were defined by their diminutive scale, this was a quantum leap. With this new size came a new confidence, and the first mammalian attempt to challenge the masters of the planet. Their target was not the armored adult, but the dynasty's vulnerable foundation, its young.
A dinosaur nesting ground at night. The air, cool and still. The newly hatched young, with skeletons still soft as cartilage, were slow and clumsy, little more than chicken-sized bundles of potential. For a swift, warm-blooded predator guided by a keen sense of smell, they were irresistible prey. Here, in the darkness, the tables were turned. The hunter, belonging to a lineage long relegated to the margins, could dismantle the future of even the most terrifying carnivores, one defenseless hatchling at a time. This was more than just predation. It was the first true intersection of their two worlds, a primordial drama of mammals asserting their will upon the age of reptiles.
For decades, this remained a compelling hypothesis. And then, from the fossil beds of China, came the incontrovertible proof. Scientists unearthed a Cretaceous triconodont of astonishing proportions, Repenomamus. It was a beast over 1 meter in length, weighing up to 14 kilograms, but the true revelation lay locked inside one of the specimens. Within the fossilized ribcage of this formidable mammal, preserved for eternity, lay the delicate bones of a juvenile dinosaur, its last meal. The evidence was absolute. Mammals did not just scurry and hide, they hunted.
Yet for all their growing confidence, the mammals were not the authors of the dinosaur's demise. Their impact was a whisper against the roar of cosmic forces. The end came not from the earth below, but from the sky above. A cataclysm of asteroid impact and volcanic fury rewrote the planet's climate. A violent punctuation mark at the end of an era. When the dust of this cosmic violence finally settled, the world was irrevocably changed. The giants were gone. The ensuing silence created a vacuum, and a new competition began, this time among the mammals themselves. From the ashes, they rose to inherit the earth, though they would have to share it with the surviving dinosaurs, the birds, who carved out their own dominion in the sky. All mammals today, living and extinct, trace their ancestry back to a fundamental schism that occurred deep in the Triassic period, while the first dinosaurs walked the earth. The lineage split into two great subclades, the Prototheria and the Theria. This ancient divergence, a choice made in the deep past, would set the stage for all that was to come, defining the very nature of the animal kingdom. In the deep archives of life, a story is written not in ink, but in bone. It is a tale of two great mammalian dynasties, whose fundamental divergence is etched into the very architecture of their skulls and jaws. During the long reign of the dinosaurs, throughout the Mesozoic era, The world's small, furred creatures were dominated by one of these lines: the Prototherians, the first beasts. They scurried in the shadows of giants, a quiet but significant presence. But as the Cenozoic dawn broke over a world cleansed by fire and impact, the tables turned with dramatic finality. The age of Prototherians gave way to the age of Therians, the wild beasts, and the planet would never be the same.
Today, the Prototherians are ghosts of their former glory. We know them as the platypus and the echidna, creatures so strange they seem assembled from myth. They are living fossils, echoes from a vanished world. For 200 million years, the blueprint of the Prototherian skull has remained virtually untouched by time, a testament to an ancient and successful design. Their competitors, however, embarked on a relentless campaign of innovation, modernizing and diversifying their anatomy. While the modern platypus would be entirely recognizable to its Mesozoic ancestors, the Therians have since exploded into every conceivable form, from the bat to the blue whale.
The evolutionary schism that separated these two great families occurred in the earliest days of the dinosaur era. For the Prototherians, time seemed to slow to a near standstill on one particular landmass. The long geological isolation of the Australian continent, a land free from major placental predators, created a continental time capsule where these ancient mammals could persist, sheltered from the fierce evolutionary arms race raging elsewhere. The Therians, meanwhile, were facing their own internal division. Sometime near the end of the Cretaceous period, or perhaps in the first light of the Cenozoic, they split into two new revolutionary branches, the marsupials and the placentals. The fossil record provides tantalizing clues to this separation. The skeletons of late Cretaceous placentals still possess a so-called marsupial bone, the epipubic bone, a ghostly echo of a shared ancestry, a feature now lost in their descendants, but retained by their pouched cousins. The engine of this divergence was the Earth itself. As the supercontinents continued their slow, inexorable drift, they separated the burgeoning mammalian families. For reasons still debated, placental mammals came to dominate the northern continents, while marsupials found their stronghold in the south. The harsher, more variable climates of the northern hemisphere may have acted as a crucible, forging greater adaptability. This relentless environmental pressure spurred the progressive development of the placental brain and central nervous system.
Today, the marsupial brain is, by many metrics, more primitive than that of a comparable placental. Yet, from the cold, hard perspective of evolutionary survival, the pouch offers a strategy of brutal efficiency. In a moment of mortal danger, a female kangaroo can jettison the tiny embryonic young from her pouch, saving herself to breed again. She can even conceive a new embryo almost immediately after birth, holding it in a state of suspended development. For a placental, the long internal gestation is a profound investment, a high-stakes gamble binding the fate of the mother inextricably to her unborn young. A crisis threatens them both. This fundamental difference in reproductive strategy has profound consequences for development. A newborn marsupial is a marvel of specialization, equipped with powerful forelimbs and musculature needed to crawl to the pouch and latch onto a teat. But this early demand for a robust feeding apparatus comes at a cost. It constrains the development of the cranium and, by extension, the brain within. And so, the placentals, with their extended protected gestation inside the womb, gained an evolutionary edge in cognitive power and behavioral complexity. As mammalian evolution charged forward, it twisted into bizarre and unexpected shapes. Modern genetics, a new kind of fossil record written in DNA, has allowed us to peel back layers of anatomy and reveal ancestries that defy belief. These investigations tell us that the closest living relatives of the colossal elephant are not other great beasts, but Thekenbranch, belong the aardvark. Even more bewildering is the kinship between the hoof and the claw. Genetic sequencing reveals that the odd-toed ungulates
The horse, the rhinoceros, the tapir are more closely reindeer and pigs, with whom they so often share a pasture.
Evolution does not march in a straight line. It is a sprawling, labyrinthine tree of life, with branches that converge and diverge in the most astonishing ways. It reminds us that appearances are fleeting, but the silent testimony of shared ancestry is written into every cell of every living thing, a deep and intricate histo.
The lines of ancestry often defy our intuition. The horse, a symbol of the open plains, shares a more recent common ancestor not with the cow in the next pasture, but with the predators of the night, the cats and dogs. The humble cow, meanwhile, traces its lineage back to a shared heritage with the leviathans of the deep, the whales and dolphins. These startling connections are threads in a far grander tapestry. Modern science reveals that placental mammals belong to one of 4 great superorders. There are the Xenathra, the strange jointed ones, a lineage of sloths, armadillos, and anteaters. From the African continent came the Afrotheria, an ancient radiation that includes rodents, lagomorphs, and the primates. Finally, the Laurocyotheria, an astonishingly diverse group encompassing bats, carnivores, and the hoofed mammals.
From tiny creatures surviving in the shadow of dinosaurs, mammals have walked a long and arduous path to become the planet's dominant class. Their story is one of endurance, adaptation, and eventual ascendancy. Yet, we can only guess what the next chapter holds. Perhaps, even now, in the shade of our own reign, future competitors are stirring, waiting for their moment to displace us from the pedestal.